class. I am here to go through Chapter 10 with you. And Chapter 10 is a segue from Chapter 9 because we take what we learned from Chapter 9, which is our valence electrons, which are always the outer N levels, and you can see 8. So they did the electron configuration for oxygen, which has a total of, 6 on the outside, 8 total, and then 6 valence electrons on oxygen. So if you do the Lewis dot structure for just oxygen, you go 1, 2, 3, 4, you do individual first, and then you pair 5, 6, which is like Hund's rule. So the Lewis structure, which applies mostly to covalent bonds, nonmetals and metalloids, you want to do the lone dots first, because these will show you where bonds form. In oxygen, it's often a double bond, but it could also be 2 single bonds like you see in water. So each dot represents a valence electron. Valence electrons are those on the outermost shell. They're the reactive ones, the ones that form ions, the ones that form bonds. We represent them as dots, but they're actually electrons. They also are not stationary. They're moving, but we represent them as stationary. And although the exact location of dots is not critical, we do them singly first, again, just like Hund's rule. And the only exception is helium, and that's because in helium, they're paired. The whole orbital is paired. It's only the one s2. So it's important to follow this convention. If you don't do the individual dots first, 1, 2, 3, 4, 5, 6, you can't see where the bonds are going to be. So if you look at this particular slide, you can see lithium's in group 1, and it doesn't really matter where you start the dot. I usually start at the top. They started on the side. And then beryllium's in group 2, and they did one on each side so you can see where the bonds form. Boron is a metalloid, so it bonds covalently, and they just did 3 dots here. Carbon has 4 dots. It can have the maximum bonds, so carbon will always have 4 bonds. Sometimes that may be a triple bond and a single bond. Sometimes it may be 2 double bonds. Sometimes it's just 4 single bonds. Nitrogen is a group 5, so if you go around, you end up with what is called a lone pair. And then you can see these 3 lone electrons, and that's where the bonds will form. So nitrogen tends to form a triple bond or 3 single bonds. Here's oxygen again. And as long as you do the individual first and then pair, you see you have 2 lone pairs in oxygen. And then you have 2 places where it can bond or it can form a double bond. Fluorine and all of the halogens have 7 around it because they're in group 7, so they have 7 valence electrons. And the lone dot, wherever you end up, means the halogens will only form 1 bond. And then the noble gases, with the exception of helium, all have 8 around them, so they will not bond. Helium only has 2, but it also won't bond. So you're trying to get 8 around them. Everything is trying to get an octet. There are some exceptions that you can see right here. Beryllium, even though it is a metal, it does tend to bond covalently. Boron will only have 3 bonds. Hydrogen can only form 1 bond. So those are 3 exceptions that have less than an octet. And then you'll see later on that when you get to phosphorus or higher atomic number, they can have more than an octet. So write the Lewis structure of phosphorus. This is actually one of your homework problems. You go around individually, and then you pair. So you end up with 1 lone pair. When you're doing the homework problems, you want to draw it on a piece of paper. And then you want to do it on the homework, and you want to toggle your arrow over. You won't do it in the PowerPoint. But in the homework, it turns into a hand, and it'll turn blue, and then you can click what you want. If you want individual dots, you need to click the individual dots in the left-hand corner. If you want a lone pair, you need to select a lone pair. So phosphorus should have 3 individual valence electrons. That means it's likely to form 3 bonds, or a triple bond, and then it has a lone pair. And again, that's because it's in group 5, so it has 5 valence electrons to do 5 dots around it. Helium, 1s2, if you do the structure, they put 2 dots next to each other because it's the only one that doesn't have 8. It has less than an octet. It's the only noble gas, I should say. So in Lewis theory, a chemical bond involves the sharing or transfer of electrons to attain stable electron configurations. Usually it's sharing, because they usually do it for covalent bonds, and that's where they're shared. Every now and then they'll do a Lewis structure for an ionic bond, but it's most common for the covalent bond to draw the Lewis structures. A stable configuration consists of 8, and again the exceptions are hydrogen will only have 2 like helium, boron will have a maximum of 6 because it can only form 3 bonds, Beryllium will have a maximum of 4. It can only form 2 bonds. And then phosphorus can have 8, but it can have more than 8. And then when you get to higher atomic number than phosphorus, it can also have more than 8. So they say the octet rule generally applies to all main group elements except hydrogen. Lithium actually bonds like a metal. Beryllium, each of these elements achieves stability when they have 2. And then there's also boron, which we talked about. And then those that have more than an octet.